Hello, and welcome to January's Feature of the Month. Today we're talking about DHCPv6 and how you can implement it in your environment. DHCPv6 can play an important role in your IPv6 deployment. It operates in two modes. There's stateful and stateless. In a stateful configuration, the client will request an address from the DHCP server and use that throughout its session. In a stateless configuration, the client will just request information such as DNS servers, domain names, etc., that it will use while it's on your network. DHCP doesn't play as large of a role in a v6 network as most clients are expecting to configure themselves based on router advertisements from your router that tell the client, here's the prefix that you can use, and then it tries to find an address that is free. When you implement DHCP, you also have to update your router daemon to tell the clients, hey, there's a DHCP server out here. You should go ask it for information. Additionally, you can tell the client whether it should expect to get an address or just information. In this demonstration, we'll set up a DHCP server, we'll look at the options that are available, and then we'll also look at a router advertisement daemon and show the settings that you need to set. So let's get into the demo and see how it's done. To create a DHCPv6 server, we first need to go to the address space where we want to set up the service. So in here, we're going to navigate. This is a unique local address space that I'm using on my home network. And so we navigate to the network, and the first thing we're going to do is set up a range. And so in this case, we'll set up a range of 1,000 addresses. So now that we have our range, this is for stateful DHCP configuration. You can configure DHCPv6 without a range and have it operate in strictly a stateless configuration. So we go and create a deployment role. Now, the interesting part about DHCPv6 failover is that it's not truly failover. In this example, what you'll see is we have 1,024 addresses. It's going to divide that up between the two servers. There's no protocols or mechanisms for failover. The theory behind IPv6 is that there's more than enough addresses to accommodate should a peer go down, the other server should be able to hand out addresses until you're able to recover. Now, the interesting part about DHCPv6 is the deployment options. When you look at the list, there's not that many that you can give out to the client. Most of them that you will hand out are the DNS recursive name servers, which is your DNS servers, and your domain search list. The other ones, I have never used them, but they're there, and you can look in the documentation to get more specific information about that. Additionally, there's not a lot of server options as well. What you'll see is most of them are lease times, such as default lease times, and DDNS updates. This is because most of the information that the client will get will come from the network itself. So now that I've created these options and the range, I can now deploy. And now that the service has been deployed, let's look at the config file. You'll see it looks a lot like an DHCPv4 config file. And what you'll notice here is you can see the split range. I can start at 15 and I go to 214, and then on the other side, the other server will take the rest of that range. And so this is how it does the failover. Since there are so many addresses, there's no need for a failover protocol. And so now that I've deployed that to my BDDSs, I'm now operating in a capability that can handle both stateless and stateful configurations. The next step in configuring DHCPv6 for your environment is to update your router advertisement daemons to tell clients that these DHCP servers exist. And the way that you can do that, in this example, we're going to use MikroTik routers, is by setting two flags on your router advertisement daemon. The one is managed address configuration. That is telling the client that you're going to be running a stateful DHCP server and that it should also request an address. The other configuration is when you want to have Slack hand out the addresses or use the Slack process for clients to get an address, but you want it to pull domain information and name servers from the DHCP server. Now, as you can see here, I also have domain servers here. Some clients don't support RDNSS, which is how the router daemon can hand out name servers. And so this can be a belt and suspenders type configuration where you have DHCP handing out name servers and you have the router daemon handing out name servers, covering all clients regardless of how they get that information. Thank you for joining us for January's Feature of the Month. I hope you enjoyed learning about DHCPv6, the stateless and stateful configurations that are possible, and what you need to implement in your environment to make sure that it works as expected. Thanks again for joining, and we'll see you next month.